Hello, today I'll be going over 8.1, which is model inverse and joint variation. If you remember from first semester, we went over direct variation. So in words, it would say x and y vary directly, and that means the equation was y equals ax. For inverse variation, it would say x and y vary inversely, and that would be the equation y equals a over x. For joint variation, the problem would say x varies jointly with x and y, and that means z. Oh, did I say x? Sorry. Z varies jointly with x and y, and that means z equals a times x times y. For the first set of problems, we want to tell whether x and y show direct variation, inverse variation, or neither. So for either one, there should be either multiplication or division. So for number 1, this would be neither because it's x plus 4. For number 2, we could rewrite this as y equals 4x, and since it's being multiplied, this would be direct variation. And for number 3, we have xy equals 12, so if we solved for y, we would divide by x, and we get y equals 12 over x, and since this is a division, this would be inverse variation. Okay, in the next section, the variables x and y vary inversely. Use the given values to write an equation relating x and y. Then find y when x equals 3. So since all of these vary inversely, we're going to be plugging it into the equation y equals a over x. We're going to plug in the x and y values that are given to find a, and then plug in 3 for x to find y. So we have negative 4 equals a over 5. And what we can do to solve for a is cross multiply. So I'm multiplying these two times these two. Since there's nothing under the negative 4, that means it's 1, because negative 4 is negative 4 over 1. So we get a equals negative 20. So the equation would be y equals negative 20 over x. Then we want to find y when x equals 3, so we're going to plug in 3 for x. And this would be the answer, negative 20 over 3. Number 5, we have x equals 3/4 and y equals 28. So we're going to plug in 28 for y and 3/4 for x. And again, we can cross multiply. So we're multiplying 3/4 times 28. So we can simplify this. 28 divided by 4 is 7, and 3 times 7 is 21. So that means a is going to equal 21, and the equation is going to be 21 over x. Now, since we want to find y when x is 3, we're going to plug in 3 for x, and we get 7. Okay, and for the last example, we're going to do the same thing. So negative 4 equals a over negative 12. When we cross multiply, we'll get a equals 48. So the equation is y equals 48 over x. We're going to plug in 3 for x, and we get y equals 16. Okay, in the next section, we want to write an equation relating x, y, and z, given that z varies jointly with x and y. So we're going to be using the equation z equals a times x times y. Then find z when x equals negative 4 and y equals 5. So first we're going to plug everything into the equation to solve for a. So we have 24 equals a times 2 times negative 6. So that's negative 12 times a. And then to solve for a, we have to divide by negative 12. So a equals negative 2. So that means the equation is z equals negative 2 times x times y. Now we want to find z when x is negative 4 and y is 5. So we're going to plug in those numbers. And we'll get z equals 40. Number 8, we have x equals negative 1/4, y equals negative 3, and z equals 15. So we're going to plug in to the equation. So we get 15 equals 3/4 times a. And to get rid of the 3/4, we can multiply by 4/3 on both sides. So 15 divided by 3 is 5, and 5 times 4 is 20. So that means a equals 20. And the equation is going to be z equals 20xy. Now we want to find z when x is negative 4 and y is 5. So then we get negative 400. Okay, and for the last one, we have z equals a times 9 times negative, oops, sorry, not z, 6. 6 equals a times 9 times negative 2. So that's negative 18a. And then to solve for a, we have to divide by negative 18. So we get a equals negative 1/3. So the equation is going to be z equals negative 1/3 xy. And then we're going to plug in negative 4 for x and 5 for y. So we get 20/3.